Hello everyone. Today I am continuing with the second part of acid-base catalysis. We have already done up to K is equal to K naught plus KH plus concentration of H plus KOH minus into KW divided by H plus ion concentration. So this was the equation. This was the equation we had earlier arrived. Now from here, I'll be continuing as part 2. The rate of reaction is minimum when the last two terms of the equation are equal. So we now get from here, we now get this equation, that is KH plus of hydrogen concentration is equal to KOH minus into KW divided by H plus concentration or concentration of hydrogen ions. So now here, as I said, this is concentration. Now if we assume concentration of these H plus ions at which rate is minimum, then that means concentration of H plus minimum. So now this equation will get converted into H plus minimum is equal to KOH minus into KW divided by KH plus and the whole term is in under root, that is this thing and this thing. It will become like this square. It will be squared. So I don't want this. I don't want to write in terms of square. Instead, what I'll do is I'll write in terms of square root, or I can write it as 1 by 2. It is the same thing. Now, from the values of H minimum, KH plus and KOH minus. If we know all these values, we can easily find the value of KW. When the catalysis is largely by hydrogen ions, then K will be equal to KH plus of H plus ion concentration. If we take logarithms of both these things, taking logarithms, log of k will be equal to log of this and log of this. They are in multiplication. This and this term is in multiplication, so we will just add it. It is simple maths. That is log of KH plus log of H plus ion concentration. But we know that log of H plus is nothing but pH. So now what we get is log of K is equal to log of KH plus, and this is pH. It is negative pH. What Scrabble did, Scrabble has plotted graphs between log of K and log of H plus, that is pH, for various reactions of this type. Now this Scrabble diagram, we can say, enables us to identify the significance of KH plus and KOH minus at different pH. So there are certain reactions which are catalyzed by H plus ions only. Let us take some examples. Inversion of cane sugar, that is C12 H22 O11 plus water will give us C6 H12 O6 plus C6 H12 O6. Okay, I'll write it 2 times. The rate of this reaction was found to be proportional to the concentration of hydrogen ions present in the solution. This type of catalysis is termed as specific specific hydrogen ion catalysis. Specific hydrogen ion catalysis. Similarly, some more reactions that are catalyzed by OH minus ions. That is only OH minus ions. Example, conversion of acetone to diacetone. Here only OH minus ions take part in the rate of reaction. Here only H plus ions are there. Inversion of cane sugar only specific hydrogen ion catalysis, and conversion of acetone to diacetone only OH minus ions take part. H3C COCH3 plus CH3COCH3, that is acetone. H3C CO CH2 C CH3 twice OH. This is another example. We can say this is one. We can take another example, that is nitro tri nitroso triacetonamine it is catalyzed by only OH minus ions. CH2 C CH3 twice. These are all bonds. C here also these are all bonded. CH2 C CH3 twice N NO these are all bonded. I'm showing it with only one bond. There may be double bonds present. So OH hydrolysis, what we get is OC CH, C, CH3 twice, CH double bond C, CH3 twice. As it will be here. There will be formation of double bonds. Plus N2 and plus water will be released. These OH minus catalyzed reactions come under the category of specific. Here it came hydrogen ion. So here it will come specific OH minus ion catalysis, that we call it as base catalysis. Here it was specific hydrogen ion constant catalysis. Here it is specific base catalysis. Now let us go ahead. General acid-base catalysis, the same topic. Let us continue ahead. The reactions catalyzed by H plus ions are influenced by the presence of undissociated acids and cations of weak bases such as NH4 plus ions. Normally, in general, all the substances which have tendency to lose a proton can function as a catalyst. This catalysis is known as general acid catalysis. I'll repeat this statement once again. All the substances which have a tendency to lose a proton can function as a catalyst, and this catalysis is known as general acid catalysis. Similarly, the reactions catalyzed by OH minus ions are also influenced by undissociated bases or anions of weak acids such as CH3, COO minus. So in general, all substances which have a tendency to gain a proton can function as a catalyst. And this type of catalysis is known as general base catalysis. So, these observations led to the development of what is termed as general acid-base catalysis. General acid catalysis include reactions which are catalyzed by any substance which has a tendency to lose a proton. Let us see here, let us see the mechanism of hydrolysis of an ester. We will see this topic in our next video. Till then, keep watching and don't forget to like, share,